Hello, we're here at the Big 5G event, and I'm Phil Harvey, Editor-in-Chief of Light Reading, and joining me is my old colleague and dear friend, Mari Silbey from US Ignite. And Mari, I completely forget your title, as I do every time.
You know, there's no, titles mean nothing these days. They tell you nothing about what a person actually does. Okay. So for US Ignite, I'm the Senior Director of Partnerships and Outreach, but more importantly, from the perspective of this conversation, I am the Program Director for the Platforms for Advanced Wireless Research program, so POWER, P-A-W-R.
I'm glad you spelled it out, because if I say power, everybody assumes my Texas accent. I'm meaning electricity, but we're actually meaning testing wireless capabilities in quasi real world situations, so that we can learn more about how it applies to either government use or industrial stuff. And so in this show, the Big 5G event, there's been a pretty big focus on Open RAN and a little bit of chatter about the technical limitations, or sort of where we might, where we might run into technical limitations or practical limitations of Open RAN. Is that something that the POWER program is looking at, and what are researchers sort of digging into there?
Yeah, I'm glad you asked, Phil.
Okay.
So the focus particularly of the first two POWER testbeds, and just to kind of set the stage for people who don't remember, this is a $50 million investment by the National Science Foundation, matched by roughly $50 million in-kind contributions from industry partners. So very much meant to marry industry research interests and assets with what the research community is looking to do. So we have 4 wireless test beds, 3 are operational today, and all of them have some component of being programmable network infrastructures that people can really come in and play with certain levers that are not available in the commercial, production networks that are out there today. Even if they could get access, for example, to a major carrier network, they wouldn't be able to make the adjustments that you could make in a truly software-defined, virtualized, programmable network. So that was one of the major ideas behind creating these test beds. So with that in mind, what I will say, and I'll kind of focus here on our platform in Salt Lake City, which is Powder. And one of the things that they have done is built up what I consider not just the physical infrastructure, but also the digital infrastructure. Which means that in addition to putting out the software-defined radios that are out there, they've also been working with the software stacks that need to work with that software, those software-defined radios, to make it possible to do the types of research in Open RAN, for example, that wouldn't be possible just using existing commercial equipment and commercial software that's out there. So, which is not in any way a denigration, by the way, on the commercial equipment, because we are strong partners with folks like Ericsson as well to do other types of research, and to they certainly have an interest in Open RAN as well. But in particular, the idea is give people a sandbox, again, in this sort of real world environment that lets them come, tinker, play with different levers, and that means everything, again, from the hardware to back in, we hear a lot about the RAN intelligent controller, the RIC, right? So the ability to be able to test out different equipment, or different, your software DU or your open radio unit, test that out with the with different software orchestration, management and orchestration stacks that are out there. So I was a little bit rambly, but you kind of get the idea.
I get the idea, because what people need to know, I think, from our audience is that there's all of this sort of conjecture around different combinations of technologies for Open RAN. That's both one of its strengths and one of its weaknesses. Obviously, you guys have already set up a program in place, and people should know there's a program in place to go and put that to the test, and also add those variabilities that everybody's so worried about, in a more or less real world scenario, so they can find out what the technology does, and also, what does it really work with, and where the interoperability gaps are.
The way I also like to think about it is there's not a private sector model for this in the sense that if you want on-demand compute or you want on-demand storage, you can go to AWS or any of the other cloud providers.
Sure.
If you want an actual radio environment that you can come and use those resources, reserve them, use them for a period of time, and then walk away, that doesn't exist. So that's kind of what these are. If you want to have a simple analogy, that's a little bit how I think about what these networks can provide.
That works. Another thing at the show, a big theme is is the path to 6G, or sort of where we go beyond 5G. Does the Power program sort of have anything happening where you're looking beyond the current, deployed capabilities of today's wireless network?
Because they are research platforms, they were never specifically targeted at, say, 5G.
Okay.
Meaning that they are meant to put all the pieces out there that people can combine them, advance them, develop them in different ways, whether it's for what comes standard in 5G or what comes next. It's to give everybody the tools in the toolbox to build what they need to, whether it's 5G or next in 6G. I'll tell you, there's some very interesting avenues of research that are happening. One being what you can do in terms of spectrum monitoring, sensing, and sharing. Okay. And that is something that the test beds are well equipped to support. One of the things that everybody's trying to do is bring in more sort of AI and ML into the loop to make sure that networks can optimize better for different environments without a human having to constantly, turn levers or whatever. Well, to do that, you need a lot of data about how networks operate in different types of environments. And so data sets are a really big opportunity to feed into these new AI and ML engines that are going to decide how to orchestrate how a network is performing in real time. And one sort of side addition to that is that our test bed down in North Carolina, AirPaw, is also focused on unmanned aerial vehicles for wireless communications, drones, UAVs, or layperson's terms, drones.
Phew, I'm a layperson, no doubt about it.
No, me too. But one of the things they can do is start to map air to ground in 3D space. If you're putting radios on drones, what does that do? Let's collect as much data as possible about doing channel sounding, seeing how that spectrum performs, how the topography changes, all of those things. Collect those data sets to be able to inform these AI and ML engines to be able to get the networks then to know and make those decisions very quickly instead of having to bring in a human over long time increments.
That is interesting. What, when and where do we find out more about the types of things they're learning, or the data that they're the data sets that they're gathering and how they're applied and that sort of thing?
Yeah. So I would say, first of all, that we're fairly early in these spaces.
Okay.
However, there are programs that are specifically being spun up to dedicate to those types of things. So for example, the National Science Foundation started a program called the National Radio Dynamic Zones, which I always called NRDZ, and apparently was literally and deliberately called nerds. Just in case you were wondering.
That's cute.
Thanks.
That's just few things that the government does are adorable, but that counts.
A little bit adorable.
Yeah,
it's a little bit adorable. And part of the goal with that is to figure out, again, try to get some of these propagation models. To get the data to inform some of these propagation models, as one example. So you'll start, that then goes to the researchers that come to get money to be able to do that research is one piece, and then there's going to determine where that stuff gets published, how it gets standardized. There's a lot of pieces to it, but that work has begun.
Fantastic. You want to gossip about your former boss, Joe Kochan? I interviewed him the other day.
Oh, good.
He has a new job now. You've probably heard.
He does.
Is this? I only bring it up because a lot of what he said sounds like things you've said in the past about public-private partnerships and kind of the need for industry to seek these things out and really embrace them. And I was just thinking it might be good for our readers, or to hear how they can get involved with US Ignite, or where or why they should look at programs like US Ignite and maybe be, if they're not already involved, be curious about them.
Yeah,
so we won't gossip specifically about Joe, but
I was actually going to do that now. I was going to gossip specifically about Joe.
We could.
No, but not surprisingly, I mean, we worked together for a certain number of years, so we have some similar viewpoints. I think the key thing to focus on his his new role and why it's important is because there are a lot of people that are working hard and a lot of people that are very smart who still only know pieces of what's happening. Like we are making things so complicated. All of a sudden, from a technology standpoint, we're bringing computing in with radio technology. That's a whole sort of new converged domain of science, right?
Yeah.
In addition, now you have different federal agencies who are interested in what they can possibly use the spectrum for and what do they need it for. So you've got all of these sort of government players. In addition, lots of quasi-government players. You get into the lobbying and regulating side. There's so much complexity, and then there's also the domain expertise, the talent side is huge. So the point being, there are smart people doing very important work, but we can't let them all do that work in different silos. So the Power program, these are meant to be shared national infrastructure assets. That's what we want them to be. And as much as possible, whether it's through things like the National Spectrum Consortium, whether it's combining with testbed programs, the more we can bring everybody together to solve these problems, and that means industry, it means government, it means the communities that they affect, the talent that they are trying to enable. That's how we're going to solve the problems, and it's just too complex to keep in a silo.
Well, there we go. No more silos, bringing everybody together, and I'm going to go get lunch. Mari, thanks so much for joining us.
Thanks, Phil.